want to change speed a little bit and talk about some improved summer annual varieties that we use more commonly, and those would be the sorghum species, which would include sorghum Sudan grass, and then pearl millet. And I will show you some work. We've been doing work with these for about a decade in Virginia, looking at both the yield and the quality of these species. So we had variety trials ongoing since the early 2000s, but it wasn't until 2009 that we started to really look more closely at the digestibility of these different varieties of summer annuals. And this is some results from the first harvest of the summer annual variety trial in 2009. We had 20 some varieties in there, but if I put all 20 on the slide, you can't read anything. So I chose 2 of the top yielding, 2 of the middle yielding, and 2 of the bottom yielding ones. We had a forage sorghum, a sorghum Sudan grass, pearl millet, Sudan grass, and Sudan grass. Some had what we called the brown midrib trait, and some did not. So what the brown midrib trait is a mutation inside that plant. It causes the midrib of the leaf, so this structure right here, to be a brown or a tannish color. That's a phenotypic expression or an outward expression of something that's different within that plant. And what's different is that plants with the BMR trait tend to have lower levels of lignin. Lignin is a compound that makes plant fiber less digestible in the rumen of the animal. So generally speaking, having lower levels of lignin is going to increase digestibility of that forage plant and increase animal performance. So some had this and some did not have this trait in this particular trial. I'm going to go back one slide. So when we looked at yield of these varieties that we had here at the first harvest, we had a big range in yield difference, 3,800 pounds to 6,800 pounds at first harvest. When I got the data back from the lab on digestibility, I said, well, for sure, those ones that yielded 6,800 pounds are going to be our least digestible varieties in the trial because they just had a lot more biomass production, they were more mature and so on. So when we started matching these up, lo and behold, some of the ones that yielded the most were also some of the most digestible in the trial. So the digestibility ranged from 54 to 74%. And some of the ones that yielded the most at that first harvest were some of the most digestible. And it kind of got me interested in this relationship between yield and digestibility of these summer annual varieties. And so we started to look at that over the years. And the first thing I want to point out is that when we had the BMR trait in a variety or we didn't have it, did impact the digestibility. This is averaged over all the varieties in these trials over the years. So we separated the varieties into non-BMR and BMR. When we had the BMR trait there, we had consistently about a 5% increase in digestibility of that forage material, which is significant. It's going to cause an increased animal performance in those varieties. And this impact of the BMR trait was consistent over the years. So we got all this data and with just tons of data, thousands of data points over the years, yield for each harvest, digestibility, ADF, which is acid detergent fiber, neutral detergent fiber, crude protein, total digestible nutrients with estimated of energy, in vitro true digestibility, neutral detergent fiber digestibility. So I put all these in spreadsheets and I give them to people and they'd look at it and they'd say, yeah, that's real nice. And then that's the last time they'd ever look at it. It was just too much data for people to kind of comprehend. So one of my goals was to try to take this data and put it in a way people could visualize what I wanted them to see from this data. And we came up with this graphic, this graph that illustrates the impact on yield and digestibility and the relationship between those two. So what we did was we took the yield for each year of the trial and we indexed it against the average. So 0 on this graph would be the average yield for this trial. And then we could rank our varieties as either being above average in yield or below average in yield. We did the same thing for digestibility. So 0 would be the average digestibility in this trial. So varieties were ranked either above average or below average in digestibility. We did this for each year of the trial. This was for 2009, the first year, and this is averaged over the entire grazing season. And then we could divide this graph into 4 quadrants. So we have varieties that have below average yield and below average digestibility down here in the left-hand lower quadrant. Those are varieties we probably don't want to put into a forage program. They're kind of dogs, okay? And then we had on the right-hand upper quadrant varieties that had above average yield and above average digestibility. Those are varieties that we might want to consider putting into a forage program. So we went through there, and each year I keep a little chart like this, and these are all varieties that performed above average in yield and digestibility in a given year. And when they have an X, that means they were above average. So we start to see these varieties that have 3 or 4 X's on them, and that means they performed well in multiple years, in multiple weather conditions, in terms of both yield and digestibility. And those are varieties that we really want to start thinking about putting into a forage system when we have that multiple years of above average performance in both yield and digestibility. And we've tracked these varieties over the years and kind of kept track of their performance. Want to share, is there any questions on that? I know that was a lot. So, I think you have to look, so I think the take-home message from this table is that you've got to look at more than digestibility and more than just yield. You've got to look at the combination of both on the individual variety for individual varieties. So when you select seed and somebody's trying to sell you a seed, ask them for digestibility data along with their yield data. That's really the take-home message. And you want something that's going to be a good performer in terms of yield, but also a good performer in terms of digestibility. And those varieties are out there. You just have to figure out which ones they are. And that's kind of what this table tells you. All right, I want to share just the first year. I moved to Kentucky last January, so I've been there 1 year. And I had a graduate student start in March, and she did a summer annual diversity study that was kind of interesting. So we looked at the impact of 3 diversity levels in summer annual mixtures on not just the animal, but we looked at the soil and then the plant and then also the animal performance. I'm going to show you just the beginning data of that that she's starting to come out with. So we had a monoculture, so no diversity, a BMR sorghum Sudan grass, and that was a good performing variety from Alta Seed. And then we had a simple mixture, and this would be all things that we could get at the local co-op. So a BMR sorghum Sudan, we mixed in some pearl millet, and then we had a soybean mixed in with it, and we used a forage type of soybean from Eagle Seeds that tends to have more upright growth and tends to be leafier than a more traditional soybean. All right, so a simple mixture, and then we had a crazy mixture. We had sorghum Sudan grass, pearl millet, soybean Sudan grass, crabgrass, sun hemp, annual lespedeza, cowpeas, rape, radish, and corn in this mixture. So just anything we could find, we kind of threw into this mixture. And amazingly, when we looked for all these species within the mixture, they were there. I mean, they were there. I'm not going to show you the botanical composition, but generally speaking, even this mixture had the 60% of it was the sorghum Sudan grass in that mixture. So that's Kelly Mercier. She grew up on a dairy farm in Wisconsin, extremely hardworking graduate student. We about killed her with this study this summer. She was clipping samples every week, moving cattle twice a week in this particular study, and it was hot out. We got great stands, and then she wasn't done when she clipped the samples. She had to take them back to the lab and separate them into each of the individual botanical components. So that mixture that had 9 or 10 different species in it, she was separating into each one of those species before she dried those samples and ground them. This was the performance. We managed the study with strip grazing, so we started at our water source. This wasn't ideal, but it was kind of the pastures that we inherited. We had a water source on one end, and then we stripped away from that water source. And so as we went through the period, you can see the biomass tended to increase. And the biomass was fairly similar for each of the species diversities. So we didn't see a big advantage in terms of total biomass production. All 12 species were again present. We can see a little bit of a soybean in here, and then also a, what was this one? Cowpea, yeah. Cowpea, and then we can see a piece of corn in there and some sorghum Sudan in there and Sudan grass in this particular mixture. So it was kind of neat, and it was neat to see the sunflowers bloom in this mixture as we went along too. So I was pretty excited about this, and I said to myself, you know, cattle are going to perform best on this complex mixture. It just gives them so much diversity within that mixture. And I was pretty excited about it. And there's a cow. So we stocked this with 6 tester animals per pasture. Then we had some extra cows to help us keep up with the forage, and actually got ahead of us even as we moved into late summer. So the growth of these summer annuals are absolutely tremendous in the summer months. So you have to be ready to stock them pretty heavy. Yeah, yeah, and if your stocking rate's not high enough, one of the management tools would be go in there and harvest some for conserved forage. And then animal performance decreases. And we did see that towards the end of the season. Animal performance did tend to increase as they got more mature. So one of the management strategies is what you just described. You can go in there and clip those pastures and roll them up as hay. Although they can be difficult to get cured as hay, baleage is a better choice because you can harvest that at a higher moisture content. So this was the animal performance, and we were a little surprised that our complex mixture had the lowest animal performance, and it was significantly lower, about 0.3 of a pound a day compared to our simple mixture and our monoculture. And we're not sure why. We don't have all the data back for digestibility yet, but we think what may be going on is in this very diverse mixture that we have 40% of that sward is something else other than that BMR sorghum Sudan grass. In those other components may be a little bit less digestible than a BMR sorghum Sudan grass, which suppressed animal performance. Now, having said that, we're testing the soil for lots of other things too. So we're looking at total microbial biomass in the soil, and that could be beneficial. Next year, we're going to be looking for insect diversity within these different stands. So we'll be actually sampling to see if we have increased insect diversity, which we would expect with the more complex mixture within that stand.